Hey guys, today we're going to start part 2 of, or day 2 of right triangle trig, and I'm going to take you through some problems that will be similar to the problems that you do on your homework tonight. The terminal side of angle theta lies in standard position and passes through point P. Find the exact value of the 6 trig functions. So no decimals, exact values will have square roots in them. Point P. We're going to sketch point P. Its coordinate is negative square root of 3, negative 2. So from the origin, negative square root of 3, negative 2 would be somewhere down here in quadrant 3. So our x value is negative square root of 3 and our y value is negative 2. We'll use Pythagorean theorem to find the hypotenuse. So we have negative 2 squared plus negative square root of 3 squared equals c squared. Negative 2 squared is 4. Negative square root of 3 squared is 3 equals c squared. 7 equals c squared. So c, the hypotenuse, is equal to the square root of 7, always positive. Now we can find sine of theta. Theta is always the angle at the origin. The sine of theta is the opposite leg, negative 2 over the hypotenuse, square root of 7. The cosecant is the reciprocal, so square root of 7 over negative 2. The cosine is the adjacent leg, so negative square root of 3 over the hypotenuse, square root of 7. And the secant is the reciprocal, so square root of 7 over negative square root of 3. Tangent is opposite over adjacent, so that would be negative 2 over negative square root of 3. And the reciprocal is, and we know that would be positive, the reciprocal would be the square root of 3 over 2. Now, all of these that have square roots in the denominators, you know we've got to rationalize. So we'll multiply by square root of 7 over square root of 7. That will give us negative 2 square root 7 over 7. And cosecant is fine. Cosine needs a little bit of work. We'll need to multiply by square root of 7 over square root of 7. That will give us negative square root 21 over 7. Secant, we'll need to work on that one. We'll multiply by square root of 3 over square root of 3. And that will give us square root of 21 over negative 3. You can move that negative to the middle of the fraction. And tangent needs a little bit of work. We'll multiply by square root of 3 over square root of 3. And we get 2 square root 3 over 3. All right. Those look good. All right, let's move on to part 2. It says, let theta be an angle in standard position. In which quadrant or quadrants can theta lie under the given condition? All right, we are going to write down the coordinates values. We know that in quadrant 1, we know cosine's positive and sine is positive. In quadrant 2, cosine is negative and sine is positive. Quadrant 3, they're both negative. And in quadrant 4, cosine's positive, sine is negative. Now tangent, we know tangent is equal to sine divided by cosine. So in quadrant 1, positive divided by positive is positive. So that's my tangent value. I'll do my tangents in pink. Positive divided by negative is negative. Negative divided by negative is positive. And negative divided by positive is negative. So these are my tangent values in pink. All right, we want to know, where do sine and tangent have the same sign? Okay, let me circle them maybe. Sine and tangent have the same sign in quadrant 1. They do not in quadrant 2, nor in quadrant 3. Sine and tangent do have the same value in quadrant 4. So that's how you will do section 2. All right, let's check out section 3. Okay, in section 3, it says find the exact values of the other 5 trig functions for theta in standard position lying in the given quadrant. So I'm going to draw an angle in quadrant 3, and so here's my angle in quadrant 3. The angle is always at the origin, and the 90 is always on the x-axis. It says that the sine is negative 4/5. One thing you always want to remember is your hypotenuse is always positive. So the 5 has to go, this negative sign has to go with the 4, because the 5 is the hypotenuse and the opposite leg is negative 4. If we do Pythagorean theorem, we'll find that we have, we'll just call that a squared plus negative 4 squared equals 5 squared. So a squared is equal to 25 minus 16, which is 9. A square root, a equals positive or negative 3. So we need to decide, should it be positive or should it be negative? It should be negative, because this x value is a negative x value in quadrant 3. Okay, now we're supposed to find the other 5. We have sine, so let's find cosecant, which is just the reverse of that. So negative 5/4. Cosine of theta, cosine is the adjacent leg over the hypotenuse, negative 3/5. And secant is the reciprocal, so negative 5/3. Tangent is opposite leg over the hypotenuse. The opposite leg is opposite leg over the adjacent leg. The opposite leg is 4. The adjacent leg is negative 3. Negative 4 over negative 3, which is positive 4/3. And the cotangent is the reciprocal of tangent, so we would have 3/4. The last section says determine the exact coordinate of the point at the given distance from the origin in the given quadrant if theta is in standard position. Okay, so we have a quadrant 2 angle, so we'll draw an angle in quadrant 2, and we drop down, make a 90 on the x-axis. Theta is always the angle at the origin. We know that it says the given distance from the origin. So the given distance from the origin is 10. So this distance is actually 10, but it says that the sine value is 3/5. So sine is, this could be a reduced fraction. 3/5 could be a reduced fraction. Like it could have originally been something else and reduced to 3/5. So the sine, sine is opposite leg over hypotenuse. So if the opposite leg is 3, opposite leg 3, and the hypotenuse is 5, so I have, what is this, what actually would this value be if it's 3/5 has to reduce to x over 10? Okay, so what would my x be? I could cross multiply 5x is equal to 30. So x would have to equal 6. You see what I'm saying? 6/10 still reduces to 3/5. Okay, so now let's find the missing side so that we could find the coordinate of this point. It's something 6. The y value is 6. Okay, so we'll use Pythagorean theorem. So a squared plus 6 squared equals 10 squared. And a squared would equal 100 minus 36 is 64 square root. So we have a equals positive or negative 8. So we've got to look over here and decide whether we should choose positive or negative. And we are going to choose negative because it's quadrant 2. Your x value is negative in quadrant 2. So this coordinate of this point up here would be negative 8, comma 6. Negative 8, 6. All right. Good luck, guys.